So I'm very happy to introduce the next speaker. The next speaker's name is Dr. Susanne Wegner. Susanne Wegner is working for Lufthansa Industry Solutions. She's Vice President for AI and Data Analytics at Lufthansa Industry Solutions, and she's talking about MLOps, how AI learns to fly. So we are very happy to hear your thoughts and considerations, Susanne.
Yeah, I'm just preparing my presentation. Danke, Lukas. And thank you very much for having me today here in this conference. And the topic I'm talking about, and you see it on my slides, I'm coming off a subsidiary of Lufthansa Group, an IT consulting company. And what I would like to start with is a small story. So if you are a passenger of an airline, you enter the airplane and everything is most of the time going very smoothly. So the passenger normally don't see what is happening in the background. So in the picture here, you see that there are many carts around, containers, you have to service the airplane, and so on. And the same is with AI. From a business point of view, you want to use AI, you don't want to care about how to operate it, and really it should run. And the drumherum, I would say in German, that's the topic of my presentation today. And why we care about that? And I brought here a small history of some of our cases. So the team already implemented around 60 different cases for different companies, internal Lufthansa Group and external. And it's not only the implementation, is for some of these cases that we keep them running it over years already. And what we really recognized is that implementing is one thing, keeping it running and efficient running over a long time is another thing. And if you really want to do that with low effort, you have to take care of that. And the major reason I have on this slide. So this is the normal roadmap. You probably all know. You start with proof of concept, and it's easy. You can do it normally quick. If you have the right data, then you're going for the implementation. You're looking for the right technology. You're testing things, implementing in that. But then you're going to the step where you really put it into operation, what we call enterprise-ready solution. Until then, no business impact was generated. It only cost you money. So the business impact is really during the operation. And that is the point. If the operation is very costly, very manual, and I will come to some cases later on, the business value for the solution is much lower. And that is one of the reasons why we came to the lessons learned. Yet implementing things, you have the challenge about technology. You have to do things, but nevertheless, you should take care how you would like to operate that. And that's the reason for what we call AI readiness for production. And here are the different areas you have to take, or we think we should take care about. The two above, it's more like the non-technical things. Nevertheless, you really should look for the right talent, the right people like data engineers, data scientists, AI engineers, DevOps. I'm coming to that later on. And really having the right culture, implementing that, and then having it in production. On the right-hand side, it's again more non-technical. Nevertheless, normally you should have the right organization, because you can do everything efficiently. If it doesn't fit into your processes, into your company, it wouldn't bring the business effect it should do. And the lower part, that is more what I would say is more the technical side, not purely, but 90%. So it's more that you have the right data, the right quality, and the security of the data. On the right-hand side, that you really pick the right AI technology. And truly, everything has to run on an infrastructure, and you need to integrate it into your business processes and really driving it. So it's more the IT side. So that's very general. Coming to an example, because I like to give examples, and that shows a little bit the challenges you could have. And I'm picking one example. And the example is it's an example from Lufthansa. And I believe it was 2018, when our catering colleagues came to us and said, okay, can you implement an AI system to forecast how many menus we need for all flight of the Lufthansa group. Today, it wouldn't be such a challenge. Nevertheless, it's still a challenge. But at that time, we had more than 20,000 meals every day. And the question was really how to predict that. Make the story very short, it worked quite well. And even now in Corona times, because we really use the DevOps, it's still working very great. And after a week, the colleagues told us that they already have the budget in their spend for the project. But coming to the operational part, because if what we are doing here is that we are taking the flight data, changing every day, as you can, not every day, but very often, as you can imagine, we have integrated the weather data, some historical data. So this data is changing. And from the beginning, we start taking the data for the training. Then we have the machine learning code. Sometimes you have to change it. And then you have the artificial intelligence models. And for all of these, you really have to take control at what time you are taking what. You really need the lineages of data, of models, what kind of code. And that's very different to normal software development project. And it might even be that the business objective changed a little bit, so that you have to adapt everything again. And here are really the challenges for such a case where data input is changing not on a daily basis, but very, very often. How do you do that in your operation? Because if you do that not automatically, as you can imagine, it costs really a lot of money. And now coming a little bit, what is MLOps? And in general, it's as I have it here on the slide, really putting together and delivering value for the business and for all the stakeholders. And it is an umbrella term for really best practice and guiding principle around machine learning. And I must say, it's not that it's one single technical solution. There are several solutions, and it's really to optimize the life cycle of a machine learning application. And the graphic shows it a little bit from the business, coming to the machine learning development, going to operation, and then coming back again, because it's very agile. And One part is, as you can imagine, with the ops in there, is about software development and the IT. But additionally, we have special topics on machine learning. What we need for that in general are the principles that on the lower part of that slide. So I mentioned at the beginning already the teams. For the collaboration, you need really the feedback you see in the graphic over there. You need a strong team structure, not only with operational people, but especially data engineers, data scientists, and AI engineers, really interdisciplinary. The next one is about standards. You need a reproducibility. You need standard tooling. You need a standard in your complete life cycle to really have an audit there and to really have the data and the model literature there. And the last one is about the overall process. So continuous integration and continuous delivery, we already know from DevOps. So it's about bringing software into production. What's new in machine learning is more the continuous training. And coming to that very briefly is just very, very short. So normally you train an AI, you have the solution and you start with the normal operation. And whatever case you have. In general, this is not enough to really keep, I would say, the AI live and running. You have to constantly evaluate that against the test data set. You have to find the average confidence level, and you have to evaluate the level of automatization. This evaluation leads to results, and from these results, not everything is of interest for non-automatically producing, but you have to keep an eye on those results that have the low confidence and those that have a very high confidence, but there's a mismatch with the test data. And for these, we need a person, data scientist, data engineer, or a domain expert to really look over it, verify that, and putting then case by case, it really depends, additional data for the training to get really new, high qualified data set. And then everything starts again, like with the training and the interference. Just very, very briefly about the continuous training. What we did is, since not every case is the same, the case I explained to you about catering and prediction of menus is a case that's changing all the time. There are other cases where you would say, I don't need to train my model every week, like we need to do that for that case, but we are training it, I don't know, every half a year or whatever. For that, you don't need the same tools as you need for the catering case. Or if you have a case where you have several models and you need to work really with multiple models, is another case than if you have only one model. We have some cases where we are calculating 10 different models and then picking the best model. And every time during the life cycle, it's changing. So that's a little bit how we put everything together. So put for ourselves a toolbox of things you need, and depending on the case we have, we put together like our architecture, how we deal with it. And now don't be surprised, this is not a failure. It's on purpose that you are not able to see the detailed architecture. It wouldn't be anyway too tiny, but I'm not able to share that. Nevertheless, what you see here is our architecture for different kind of cases. And even though you're not seeing every box here, you see that it's quite different. This one is very complex. So this is more a model where you have to really change things all the time and take more care about that. This is an easiest one, and this is more in the middle. So we have diverse templates, toolboxes we already put together as best practice for different cases we are developing and putting into operation. And as you can imagine, you see it here, we didn't develop everything ourselves, but using standard tools, and I'm coming to the tools later on. And just giving you one example, and this example is from one of our projects. It's again an internal project, was called about Makerspace AI, where we did for our technical unit something where we had 12 AI experts, and it was about community collaboration. They were sitting in Corona times, it would be a little bit more complicated. Sitting there together with the domain experts, and every domain expert could come discuss real cases with them, and they were able to really do very quickly together some proof of concept, very successful, and to bring these ideas relatively quickly from POC to MVP into operation. We developed this MLOps toolbox with the architecture and everything I showed. So that was a little bit the start with this project. And it was not for fun. And you see that on the right-hand side, depending on the different cases we implemented, we had, as you can imagine, pure cost reduction. We had, in some cases, it was here about text analysis, efficiency increase, and we saved, for other cases, again, 1,000 of working hours. In a way, it's still money, but the initial trigger is a little bit different. And as I mentioned, we are not doing everything ourselves, and this slide is a full slide, so sorry for that. But what I found very interesting is the recommendation, and that might be additionally interesting for you, on the Neptune.ai blog about tools they recommend as the best tool a data scientist should know and use for MLOps. I put this on the right, here on the left on the slide. So it's a very busy slide, but you see really their recommendation here for the different steps of data pipelining, run orchestration, experiment tracking, the hyperparameter tuning, model serving, and product model monitoring. So the basic steps, it's always a little bit overlapping, but I find it quite interesting. At least you have some guideline. On the right-hand side, I put the tools that we are using in our Makerspace AI. So it's not one tool per unit. So sometimes we are using different tools that has to do with the different requirements you have for the different cases. For some, we are using just one version. But as you can imagine, our toolbox is developing over the time, and every use case a new use case. We are checking about our lessons learned architectures and the component we already have. And as everything is developing, we're integrating new tools permanently into our toolbox. Just a very brief overview here, and I can really recommend if you want to get an overview to check that blog. So that's basically my presentation, and I hope I gave you a good overview coming from an airplane and passenger of airplane to how AI flies, or how we are bringing AI really into operation and keeping it very, very efficient in operation. Thank you very much, and I'm happy for any questions.
Thank you, Susanne. Unfortunately, due to time, we're not able to take some questions, I think, but there are a lot of questions in the chat, and I think your presentation was very interesting and very insightful as we see all those questions. And feel free to connect to Susanne after her speech, and to talk about her, to chat with her about all those issues regarding AI governance, AI lifecycle management. Thanks a lot, Susanne.
Lucas. Hi.
Bye.